For the function q, the value of q of x decreases by 45% for every increase in the value of x by 1. If q of 0 equals 14, which equation defines q? Okay, so we need to find which one of these exponential equations here matches up with the scenario. So the problem statement tells us that q of 0 equals 14, which means that when x equals 0, the value of q of x equals 14. So let's just plug in x equals 0 into all of these answer choices. So for the first one, when we plug in 0 for the value of x, so x here will just be 0, so 14 will be raised to the power of 0. And so 14 raised to the power of 0 is just 1, since anything raised to the 0 power is just 1. So we'll just be left with 0.55, which is not equal to 14, like the problem statement said it should be. So answer choice A is incorrect. Then answer choice B, we have 1.45 times 14. We'll plug in 0 for x, and then we'll just be left with 1.45, which again is not equal to 14, so answer choice B is incorrect, because so A and B didn't satisfy the condition that q of 0 equals 14. So let's check C as well. So we'll have 14 times 0.55 raised to the 0th power, which is just equal to 14. So that's good, because it satisfies the initial condition. And then answer choice D, 14 times 1.45 raised to the 0th power is also equal to 14. Okay, so C and D both satisfy the condition that q of 0 equals 14. Now we need to check which one satisfies the condition that as q of x decreases by 45% for every increase in the value of x by 1. So we can check that by looking at the base of this exponent here. So when we plug in a value of, say, 0 for x, we get 14 for each, which means that the next value, when we increase x by 1, so when we're going from x equals 0 to x equals 1, the value of q of x should decrease. So let's plug in a value of x in 1 for both answer choice C and D. So let's do C first. So we'll have the 14 times 0.55 raised to the first power. So this is just 14 times 0.55. And we know that this quantity, since 0.55 is less than 1, this quantity is less than 14, which means that when we went from x equals 0, which had a q of x value of 14, to x equals 1, we got a value that is less than 14. Okay, so that looks good, but let's check answer choice D. So when we plug in value of x equals 1 for D, so we'll have the 14 and then 1.45 times raised to the power of 1. We'll be left with 14 times 1.45. Okay, this quantity here is actually greater than 14, because 14 times something that is greater than 1 will always result in a larger number, since 1.45 is greater than 1. So, but that goes against what the problem statement said, because as the value of x increases by 1, q of x is supposed to decrease by 45%. But answer choice D said that it increased. So answer choice D is incorrect. So answer choice C is correct, because it satisfied both conditions.